At first glance, the equation x to the power of 4 minus 10 times x to the power of 2 plus 9 equals 0 looks intimidating because of that high exponent. Solving a fourth-degree polynomial, also known as a quartic equation, usually involves complex division or finding rational roots by trial and error. However, if you look closely at the structure of this specific problem, you will notice a very helpful pattern. Notice that the powers of x are all even numbers. We have x to the power of 4, x to the power of 2, and a constant term. Because 4 is exactly double 2, this equation is actually a quadratic equation in disguise. To reveal this simpler form, we use a method called substitution. We start by inventing a temporary variable, which we will call u. Let us define u as being equal to x to the power of 2. By logical extension, if we square both sides of this definition, u squared becomes equal to x to the power of 4. Now, watch as we physically swap these terms into our original equation. Where we saw x to the power of 4, we place u squared. Where we saw x to the power of 2, we place u. The equation transforms before your eyes from a complicated quartic into a standard quadratic. U squared minus 10u plus 9 equals 0. Now we're on familiar territory. We can solve this new equation by factoring. We are looking for two numbers that multiply together to make positive 9 and add together to make negative 10. If you consider the factors of 9, the pair negative 9 and negative 1 works perfectly. So we can rewrite the quadratic as the quantity u minus 9 multiplied by the quantity u minus 1 equals 0. This gives us two simple solutions for our temporary variable, u equals 9 and u equals 1. It is crucial not to stop here, as finding u was not our ultimate goal. We must solve for x. We now bring back our original substitution. Since u is equal to x squared, we replace u with x squared in our solutions. This gives us two new equations, x squared equals 9 and x squared equals 1. To isolate x, we take the square root of both sides. Remember, when you introduce a square root, you must include both the positive and negative roots. The square root of 9 gives us positive 3 and negative 3. The square root of 1 gives us positive 1 and negative 1. So we have found four distinct solutions: 3, negative 3, 1, and negative 1. If you enjoyed this explanation, hit subscribe and check out our other math videos.